My apologies. Just give me 1 second here to start sharing my screen. All right. Mark, does that look good?
It does look good, yes.
Fantastic. Well, hello and welcome, everyone. We're thrilled to be here today to talk to you about a really special project that we did that leveraged synthetic data to benchmark a cloud-based FHIR API. My name is Sunnie Southern, and I'm the Vice President of Health and Life Sciences at Onyx, and I'm joined here today by Treece, who's our Data and Analytics Practice Lead. So first of all, who is Onyx? So we're a premier cloud solutions provider. We've been serving health and life sciences organizations since 1993. So we have some unique experience and perspective on health and life sciences organizations' journeys for a very, very long time. And when our founder saw the opportunity for cloud, we really jumped on the wagon, if you will, to help our customers to adopt cloud technologies. We were Google's first enterprise partner in 2002. We've been awarded Google's Healthcare and Life Sciences Expertise designation, and we have 120 Google technical certifications, and we're an 11-time Google Cloud Partner of the Year. And we have a special way that we organize our professional services organization. We have 4 different practice areas: cloud adoption, application and modernization and migration, data and analytics and managed services, so that we can really help customers wherever they are in their cloud journey, whether it's just getting started or it's maintaining what they've built. And Dale is really going to be talking to us today about our work because he is our data and analytics practice lead. So what are our learning objectives today? First of all, we know through the many, many years that Onyx has been working in this space, as well as our own personal experience, that one of the biggest challenges that we have in health IT in testing applications is finding realistic patient data that we can use to test these applications. And for years and years, startups and other customers would come to us and that aren't actual providers, needing to have a data set that they can use to start figuring out how to test their applications. And so that was one of the first challenges we had to overcome with our work. And so we're going to talk about that today. The second thing we're going to talk about is storing API calls and related data for visualizing and reporting as part of designing this effective experiment. Then we're going to define the measurement points that we use for running the predefined FHIR API app operations. We're going to talk about how we can test applications without risking misconfiguration of sensitive data. And then last but not leastly, about how to scale and benchmark healthcare applications in the cloud. So let's talk a little bit about how Onyx got involved in this particular work. So because of our years of experience in working in healthcare and the needs that we saw within our healthcare customer base, the need for interoperability and the importance of being able to leverage data from multiple different systems so that they can make informed decisions and power applications that provide better experiences and more real-time information for better decision-making for clinicians, physicians, and of course for patients. And so when Google released the news that they were creating this cloud-based healthcare API on Google Cloud, we jumped on the opportunity to be part of the early trusted tester program. And so we started testing and using the application, looking at how it could apply to our customers' environments and speaking with our customers about it. And because of that experience, Google asked us to do this very special benchmarking work. And that's what we're going to talk to you about today. So the goal of our project was to benchmark the performance and scalability of the Google Cloud Healthcare API with 50 million patient records or 26 billion FHIR resources. And so I'm going to hand it over to Dale now, who's really going to talk to you about the experiment. Dale?
Thank you, Sunnie. Good morning, everyone. I just want to run through the first slide there. It's just a summary of the objectives and what we want to share with you today in regards to the benchmarking of the Cloud Healthcare API. Of course, the very first thing, we need to thoroughly understand the API, the methods, how to utilize them, execute them, the responses, all those kinds of things. That's just probably obvious. But today we want to discuss, our benchmark objectives, our scope, our primary metrics, the planning that went into the execution of that benchmark test, and of course the generation of the synthetic data set that was used for testing that Sunnie was alluding to. And at the end, we'll touch on some of the results and key learnings. Next slide, Sunnie. Thank you, Sunnie, for driving the slides for me. I appreciate it.
My pleasure.
So, the Google Healthcare, I'm probably not going to say a lot of things that you don't already know. The Google Healthcare API, its primary purpose is to provide that ease of integration of health data into Google's entire ecosystem, to give access across a multitude of managed solutions for ingestion, storage, access, consumption, and out of the box, without a lot of effort on our part, it's secure, it's compliant with security standards and regulations, it scales, it's reliable. And so it just, it helps us simplify our goal. Our main goal is to break down these data silos, enable the use of all of the capabilities that Google provides for us. They're a leader in many of these areas, and advanced analytics. It allows us to correlate, across data sets that might have been previously siloed. So we can do things like streamline operational administrative processes. We can, identify and treat disease. We can personalize patient treatment, et cetera. There are three modalities that standards that the Healthcare API supports. We're going to focus on FHIR today, and those commonly used FHIR API methods. Next slide. So FHIR, the API methods are primarily broken up into, a few different categories. We're just going to touch on those really quick. There's some administrative type activities, configuring, creating, listing data sets and stores, data access and control, the creation, the update, delete, or searching of data in the store, bulk import and exports, security, managing access to the data, and even de-identification, even some capability to see the methods and have those described to you and how to interface with those. You'll see later in a presentation slide that a set of commonly used FHIR methods were chosen for this initial benchmark. Sunnie, feel free to inject anything you want to as we're going through this. I want this to be relaxed and conversational. As we stated earlier, the real purpose of the Healthcare API is to simplify that data access, right, to those multitude of Google managed services. Abstracts away the complexity, enables the ease of configuration, ingestion, management. The benchmark allowed us to actually exercise that notion, right, and to gain a better understanding of how to configure, deploy, implement the HCA API and to utilize it. So what does, one of the things that we mentioned up there a couple of times, right, is managed service. What does a managed service mean? It's a very important thing for us, right? Google's managing for you, for your workload, the import speed and performance, the scalability, the availability, all of those kinds of things that typically on premise that you've got to do. It reduces the total cost of ownership. What is the main goal here? It's to spend more time focused on things that matter, right? There's a Harvard Business Review. 80% of analysts or scientists' time is spent on everything but the analysis of the data. So the goal of the Healthcare API and all of the various Google offerings is to flip that for you. We want to flip that so that the majority of your time is spent on the analysis of the data, the innovations that we can derive from it. Next, I want to sort of dive into the benchmark scope. So basically, you'll see a table to the right. These resources or steps, you'll see the word steps in there. We were actually implementing and ingesting into Firestore the data sets in incremental steps. you'll see out there low profile one, we were doing step resources of 5.2 million resources. At the end of that profile is about 52 million. Totally 52 million resources. We're using, groups of patient records to accomplish this. And in load profile 4, you'll see we got up to 26 billion total resources. In each step, it is a measuring point for us. So the APIs that we'll talk about here in a few minutes that are under consideration for this benchmark, we capture all of the metrics associated with those in BigQuery for analysis later. So, we capture start times, end times, and in case of calls that are asynchronous, we also record, the final callback, confirming that operation was complete. Next slide, Sunny. And you'll see here that, we selected some of the more commonly used methods of the API for this test. Some key points I want to point out here is that we organize and automated the execution of these methods being, that are being considered here. You'll see the word test harness later. Test harness is nothing but just the aggregation of scripts and tools and organization of those and automation around those. That's extremely important. We'll talk about that here in just a few minutes. But all of these method names, all these methods that we utilize as part of this benchmark are listed in the table above. And we're capturing response times, like I talked about earlier, response times for each API, for each individual load profile step. Any response or error codes that we got, and then the FHIR store size after each run. So we're importing data in steps. We're executing all of scripted out the exercise of these various methods.
Dale, I'm going to take you up on your offer to interject for just a second and just mention the fact that while these are the APIs that we tested, there are more that are available even today, and there will continue to be more APIs available as Google continues to invest in this specific space to help eliminate these data silos that you mentioned early on.
Yeah, that's a perfect point, Sunny. There are other methods that are in the API, so this is by no means all there is available. It is, the commonly used ones that were selected for this benchmark. All right, so next, I think we're looking at the execution plan here. Pretty simple. We're launching some compute instances to run Cynthia, which is a product by MITRE that we use to generate our synthetic data. We'll talk a little bit more about that in a slide or two. We created the storage to store all of that generated data. We spun up compute instances, to generate that data. We generated data for multiple states. We'll talk a little bit about that in a couple of slides too. Then we import the data, we execute the test scripts like we talked about in the previous slides, as we step through each load profile, and then collect all of that data in BigQuery. One of the benefits of the cloud, think about this: if you're on-prem and you were buying servers and trying to set this up, it could take months. And the beauty of this is that your pay as you go. It's cost effective. You can fail fast and reconfigure and execute again really quickly. Same day. You'll see later where we did some testing when we're prior to actually generating the data to try to determine what instance type sizes, things like that, storage space necessary, all those kinds of things. And the cloud gave us the ability to do that, to make it so that our test ran smoothly. We could automate, we could really have a successful, consistent bench test. Another point, very inexpensive storage. There's a lot of volume here. There's a, and even outside of this synthetic data set, the volumes can get huge, right? But it's there's some very inexpensive storage mechanisms that Google makes it available. So it's easy. If you want to keep all your data, it's really not that expensive, right? And then the Cloud API abstraction of that interface to Google Managed Services makes things easy. You know, the time it took to set up, to configure, was really small, and the cloud, the benefits of the cloud allow us to do that. Next slide, Sunny.
Did you see it change, Dale? We're on the MITRE slide now.
It's okay. Yeah, I see it. So I talked about Cynthia. It's a very popular open source patient population simulation, and it's a very good fit for this, for system implementation, for testing, for training. And in this case, we're trying to establish a performance baseline, right? It's a clean data set. We're trying to not inject any other anomalies in there so that we can, establish that performance baseline for the healthcare API. Like I talked about earlier, to plan for the experiment, we ran and tested Cynthia to understand what kind of solution and infrastructure requirements we would need. I think we did around 30 different executions or simulations that were executed till we got to that point. And the cloud, the beauty of the cloud is just that, right? I mean, we could make changes and shut everything down, and execute it again, really quickly, and inexpensive. Think if you're trying to determine this before you actually go out and purchase hardware, that would be a real mess. There were a lot of results and observations of that those initial simulations and executions, around memory allocation and JVM setup and recommendation of using, multiple cores to generate the data, parallelizing the load, while we're generating that data. Sunny, at the end, she'll show you that we're working on a white paper where a lot of the details, this meeting will not allow us to go into all of the minute details and all of the results. But there's a white paper that's coming out fairly soon that will allow you to examine that in detail. Next slide, Sunny. So we were talking about the synthetic data set. So around 50 million synthetic patient records produced about 26 billion resources, which is the target that we initially set up. About 13 to 15% of the population, and so 13 to 50% of the population of each state is used to create that representative data set, with a key term there, representative. The data represents the patient health patterns of that state. And I think in the white paper, you'll see that, some of the things we did to actually accomplish that. Each data set is stored, and the creation process, we'll talk a little bit more about this. Automation is key. Automation is key in testing, but it's also a key in almost everything in the cloud, for consistent, repeatable, reusable processes. It speeds up, any number of different types of use cases that you might encounter.
So Dale, if you don't mind, I'd like to interject here for just a second, because I think that when we started this process, and at the beginning of this talk, we talked about the fact that finding that realistic but not real patient data set was critically important for our ability to be able to do this kind of work. Because of course, no organization and no person would want us just taking their health data and using it to do internal testing for this type of work. So Cynthia provides that great foundation. And the other thing that was important, we needed to look at making sure, as you said, Dale, that we had an adequate representation of the population of the United States. And as the people on this call are very familiar, that the number of FHIR resources per patient is going to vary based on the conditions that particular patient has. So, a a teenage boy who is in perfect health is going to have many less FHIR resources than a 75-year-old man who has a heart condition and diabetes and maybe prostate cancer and all kinds of other things. And so we also know that the wellness or sickness of the populations across the United States vary. So, it would have been real easy for us to take, 1 million records and replicate them 50 times, but we didn't. We actually generated, and that was part of the time that it took for the experiment, was to generate a representative patient population for each of the states that we could then leverage to make sure that our testing would represent the US population.
Awesome point, Sunnie. Thank you. Let's go to the next slide. We actually went through the experiment planning. There was a table outlining the different steps. This is just another, more visual representation of that. We're generating the Cynthia data set with compute instances in Google. We're storing that in cloud storage. We are running our test, executing, we're importing our data into Firestore, we're running our test, and then storing our metrics from our responses and results in BigQuery for analysis later. Anything there, Sunnie, that you want to add?
Yeah, I would just want to mention, or have you mentioned, just about the fact that we primarily used an unoptimized out of the box configuration for these results, because we wanted the average developer who's just getting familiar with Google Cloud to be able to repeat what we did. And I think that's a really important point to bring up, is that part of the reason for doing this was so that we could obviously get our results and learn ourselves, but also through the white paper and other communications efforts we're going to be doing, we want other people to be able to repeat this, because the challenge we have in healthcare, especially interoperability, no one company can solve, not even, frankly, Google. So we need lots of people, lots of developers, even those that are new to healthcare and new to the cloud, to be able to repeat this experiment and help us to solve interoperability.
Yeah, 100%. And I'm going to touch on that a little deeper too in some other slides. About the subject you just mentioned. Yeah, and I just want to pile on one thing there. You're talking about this area, this vertical, this domain. It means a lot. It's different than other verticals. This is impacting humans. So this work is important, and what Google is doing is important in that we're abstracting away a lot of the time-consuming stuff, and allow us to focus on the analysis of the data, so that we can come up with a new treatment for a disease. We can, the patient procedures that we perform, the patient care can be very specific to a customer, come up with cures. Those things are important for humanity. So next slide. So I talked about a test harness. Test harness is nothing but, just an automated, a collection of scripts, software, test data, tools. It's a framework that allows you to organize, to automate, to control the conditions in a consistent, reliable, accurate, and efficient way. And it's very important. I can't, of course, all the data, of course, the interaction with the healthcare API is important. And like Sunnie was saying, we learned a lot from, how to deploy and implement and utilize it, and some of the little things that happened, that, little scars that we got, from this exercise. To me, one of the biggest things here is just this environment, the automation of it, so that you can tear everything down, again, a benefit of the cloud, and come back, and you're back the way you were or needed to be, because you have all of this framework in everything's in position, and it's organized to be able to execute. there are tools out there, but in this particular case, there are tools out there to help you do that. But in this particular case, we built a lot of it ourselves, specifically for this benchmark. Next slide. I'm missing a slide. The one with the table for the different compute instances types. If it's gone, it's okay. I'll talk to it.
Yeah, I think it got inadvertently deleted. Do you want us to pop it back in and you can speak to this and we'll bring it back over?
I can talk about it. I can paint a verbal picture.
Isn't that the next slide?
No, it's not the next slide. I know which one he's talking about. You know what, Dale? You sure? Because I can pop it in.
No, I got it. I'm going to paint a verbal picture. It's real easy. So one of the things I talked about is where we were doing some preliminary type work to determine the instance types, the number of CPU cores, disk size, total RAM, all those kinds of things. And then the thing I just wanted to point out there is that there was some variations as we stepped through the different load profiles, and the various step sizes changed. We were given the benefit of the cloud of being able to change our instance type that we were utilizing really easy, and it helps us become more cost effective. We can optimize the cost of the operation without penalty. You pay as you go. No upfront capital costs. I didn't have to buy these different things. I didn't have to buy some big huge machine and use it for all of my test iterations. I could be very cost effective and pay as you go. So it's all about the advantages of a serverless architecture and the managed services that Google has and that this API enables us to use. Right,
Dale, if you want me to pop that slide up, I don't want to interrupt you, but I've got it at the end. Do you want to go ahead and go to it for a second?
No, I'm good.
All right.
I think that was good.
It was great. That was great.
Okay. So the next slide is, it's a little busy, and there's a lot of stuff here. You could look at, these are actual plots of some of the various API calls through the load profile sequences. I see some anomalies right now. I'm sure you do. We call those out and spell those out in a little bit more detail in the white paper that's coming out. But you can see some of the high level information over to the left. 50 million total patient records. They ended up creating our goal of somewhere around 26 billion FHIR resources. Source data was about 60 terabytes. Total amount of data ultimately ended up being about 80 terabytes in the FHIR server. Our import speed, this was out of the box. There's tons of knobs and switches that you can use to modify this and to make it, to increase your import speed. We were running about 1 million records a day, which was max resources per second would be something like 10K. It would change and vary throughout the day. But we would get, 10 point something K resources per second. On average might be a little less than that. I can't think of anything else there. There are some anomalies that I see right there. Like, for example, if you look at like the fourth pane over at the top, when the Firestore was completely empty, it took a little bit more time. It's almost like a warming kind of thing. And you can see over time, as we're injecting more and more data, that response time went down. Also, we had an issue where, we were trying to really push the import speed, and, you can request limit increases through Google. There is a default limit there that will cap you. But by increasing that, and there's also some things you can do from a sequential versus parallel type setup. We increase some test speed 2 to 3 times that 1 million. And I think there's more room for that. Again, I know I see some of the little spikes there. There's one spike like in the middle, the conditional patch. There's a spike there in load profile 2. And we think that was an anomaly that was outside of the API, more networky kind of stuff that impacted that. But a lot of this will be called out in the white paper. I don't think I'm missing anything there, Sunny, at all. Again, there's a lot more detail, measurements around. I know there's some charts for response times and things like that. You'll see those. I know out of this exercise, Google was doing some optimization of their search API. And so this work helped them. And like Sunny said, it helped us gain experience and build our ability to accelerate this for our clients. Next page.
All right, Dale, if it's okay, I think maybe we should go on to the key learning. So I'm going to skip the next slide. I'm going to go kind of fast, and if you want me to stop, I will. But I think we're probably ready to talk about the key learnings.
Yeah, I want to skip slide there. That one is a little different in that it's not my favorite. Let's put it that way. It's valid information, but it doesn't really stand out to me. So in the key learnings, there are a lot of things there. I could go on for probably the rest of the time on this. So, set up an implementation. We like we've talked about, we've increased our experience and understanding of the healthcare API, and we've enabled our own selves to accelerate, the deployment and the adoption of that. We had some issues with setup and implementation and execution. Even down to things like, the format of the JSON that's being generated by Cynthia. It's, pretty versus non-pretty kind of thing, where we had a few things happen that along those lines that it impacted, the full record actually being imported in. And I've already talked about, loading and import tuning, parallel versus sequential, and a combination of increasing those capacity limits, which you can reach out to Google to get done. The capacity actually bit us once, and when we were trying to execute the test. Another key learning, I think, is the test harness itself. I already pointed that out. It's just so important for consistency and for organization and for repeatability, and to make our execution of the tests, productive and efficient. And also that consistency can help us eliminate errors. So, I like to say automate, testing especially, but, and in general, it's just a great practice in the cloud, to get that consistency, no matter what you're doing. If you're developing, an application, if you're developing, a data lake foundation, or you're developing ingestion or transformation pipelines of data, automating those things, really is a great practice. It allows you to speed up and drive more, become more rapid in getting to a data-driven decision. We talked a little bit about total cost of ownership, security compliance. It's built into GCP. You don't have to manage or take care of a lot of the things that Google's taking care of for you. It's secure, it's scalable, it's private, it's compliant with a lot of the regulatory arms that are out there that govern our data, and it's managed for you. The healthcare API is easy to use. It seamlessly allows you to take your data, ingest it into the platform, and then integrate it into the whole GCP ecosystem, make it available. That in itself really adds to this whole concept of interoperability, right? You're getting data in there and you're democratizing the access of that data. You can control it, but you're democratizing it so that many things can go on. You can correlate across maybe data domains that were siloed previously and were difficult to do. Again, back to that Harvard Business Review, we really want to take advantage of the cloud to speed up our discovery, our treatment of diseases, our cures that are coming. We want to speed that up and get rid of all of the the overhead of managing our infrastructures. One important thing that we had to is cost monitoring and alerting. That's, as a reseller, we have some tools that a reseller of Google, we have some tools that come with our resale agreements that are really important, but you don't have to have those tools, but they are nice. And that, monitoring your costs and making sure that you don't exceed, some limits or boundaries that you set from a financial perspective, it's really important. I think one more slide, Sunny, and then I can turn it over.
There you go.
So this is just basically a pattern we follow. I've been in this business for 35 plus years, built my first big data platform many years ago, before a lot of the services that are there now. And there's patterns there that, it's cloud provider agnostic, even client agnostic, or domain or vertical agnostic. And but what the key point today is the healthcare API. The pattern doesn't change, but the healthcare API is just another tool that this makes us faster. We follow that pattern. It's a tool that we can plug in and really expedite our move to the point of driving our data decisions, deriving insights, utilizing machine learning and advanced analytics to derive, those innovations, those new cures, those new revenue streams, those, all the things we've talked about. We've got experience in walking through this process of assessing where you're at. We want to come to where you are and help you build forward. I don't want to spend a lot of time on this. Sounds a little salesy. So, but we do have experience and can accelerate you past some of the stuff that's difficult and hard. And Sunny, I'll turn it over to you, because I know you're going to talk about the way they can connect with us.
Yeah, absolutely. But Dale, before we do that, just for one more minute, I would like to kind of put a pin in some of the things that you said. And when we think about the healthcare environment that we are all living in today, I mean, there were a few people that may have anticipated it, but in the end, to have to live it is something that is pretty incredible, right? Where access to information wherever you are in real time, it always has meant life or death, but today that means something totally different with the pandemic that we're all experiencing. And so we don't have 3 months to set up a server and get teams up to speed for the next 6 months to learn how to use it. And so I think it's just critically important that we have tools like Google Cloud and the healthcare API that are fast to configure and keep people in the parameters following compliance guidelines like HIPAA and PIPEDA and GDPR, so that we can kind of protect people from themselves at times. Sometimes we need that, but also have partners like Onyx that can accelerate the learning of those teams. And, from working with you and the rest of our practice leads, we're very happy to go in and meet customers wherever they are. And whether they want us to stay for the full journey or they want us to do a part of it and hand it off and educate their team so they can take over, I think we're happy to do whatever makes the most sense for the customer. All right, exactly. I see the red, so I'm going to go to the next slide then, Mark. So as Dale has spoken about several times throughout this presentation, we are producing a white paper that will go into greater depth and also be a document that you can use in order to help with your use of the healthcare API and how we did benchmarking. Or you also may be interested in benchmarking another product that you're creating or platform that you're creating that may be in Google Cloud. And so there'll be the ability to leverage the learnings that we had from the healthcare API to apply to benchmarking other types of applications. And so the white paper isn't ready quite yet, but if you'll go to onyxnet.com/HLS/white paper and sign up, we'll be sure to send you a message as soon as it's available. Actually, we'll send you the white paper once it's available. Matt has also chatted that to you, and so you can find it in the Whova app. And if you would like to reach out to us directly, you can reach us at hls@onyxnet.com or find us on the website. And now we're going to take a couple minutes for a couple of questions. So we'll hand it back to Mark.
Thank you, Sunny and Dale. This was a great presentation and certainly a huge effort that you've undertaken in doing this not so small data set. So we do not have any questions in the session Q&A yet. They might be coming up. So anybody feel free to ask questions. I do have some. So you used the Google FHIR API. So what was your experience in terms of user friendliness, documentation, etc.? Of course, with an effort like this, you will always run into some issues, but was this harder than expected or easier than expected?
Well, so Dale, do you want me to take that or do you want to take it? It's up to you. Well, you're on mute. I'll start since you're on mute. So I would say, Mark, our engineering team, I think, had a really very, very positive experience. And because we were part of the Trusted Tester program, we had great access to the Google Cloud engineers who were incredibly responsive and really helpful. And so our overall experience, I think, couldn't have been better as far as the whether we were using the documentation that was just readily available or when we ran into a challenge, we needed to reach out to the Google engineers and get some additional support.
Right.
Yeah, I just want to pile on that a little bit, Sunnie, and that the FHIR API has done a really good job, I think, of abstracting away a lot of that, making it easy for us to utilize the FHIR standard and the API specifications there. There was a huge time savings in the ease of use. Again, I think I mentioned it earlier. Think about the time that we used to have to spend, to purchase, install, and manage, and all of that. It's back to that same thing. We want to get away from those kinds of things, and I really feel like, not only in this particular instance, there's several other instances I've had experience with where that's the case. It's speeding up. It's allowing you to get to the high value targeted outcomes much quicker and just speed up and make our data-driven decisions, our innovations around data, we can get there much quicker.
Yes, thank you. You mentioned that there's a low total cost of ownership where using cloud-based FHIR APIs. Prima facie, this is of course credible looking at the presentation and the data. But do you have any grasp of the relation to the total cost of ownership for other options? And other options mostly would be on-premise stuff, servers. So
we do. I like the word total, and Sunnie, you can jump in there too. Total cost of ownership is one of my favorite things to talk about, in that it's more than just the cost. We do have some numbers, Sunnie. I don't have them in front of me. I know there was some significant savings just between, just the, from the infrastructure perspective. But, you got to take into account all of the time spent. That's hard to really call out or to visualize, right? In some cases, it's hard to grasp or put your arms around it, in that a lot of the management overhead that typically we had to do in the past, has been reduced or eliminated. Especially if you really go serverless architecture first, and automation, again, automation is just huge, and couple that with the benefits of the cloud, that lets you get to, like I said, the targeted outcome much quicker.
well, thanks again, Dale and Sunnie. We're almost out of time. I do not see any questions by the audience, but you can always pop in questions in the session Q&A later, and Dale and Sunnie will be able to look at those. I am really looking forward to the white paper with all more detail promised. And thanks, this was a great presentation and a very convincing case I think you've made. So everybody, thanks for attending. Hope you enjoy the other meetings, and see you in one of the other meetings, hopefully.
Thank you, Mark.
Thank you, Mark, for moderating. Take care, everyone. Good luck.
Bye. Bye.
Bye.